All right, today we are talking about lesson 10.6. Lesson 10.6 is our problem solving lesson for chapter 10. And here we're going to be changing between both customary units and we're going to be working with metric units and story problems. Before we get started though, we're going to go over a quick review of yesterday's lesson, which was on the metric system. The metric system is nice because it is a base 10 system, and that makes it really easy to change from one unit to another. So for example, if we were going to convert centimeters into millimeters, and we had 5 centimeters of something, we wanted to know how many millimeters that is, we would just simply need to multiply because we're going from a larger unit to a smaller unit, and we're moving one unit over in our metric system. So we're going to multiply by 10 one time. So 5 centimeters is the same as 50 millimeters. In the metric system, we have our base here in the middle, and this is going to be grams for mass. It's going to be meters for length and liters for capacity. As we go larger up the scale in terms of size of units, our first one over is going to be our deca units, and this is going to be 10 times greater than the base unit. So for example, if we were working with grams, this would be decagrams. The next one over than that, from that, which again is 10 times larger, is going to be our our hecta unit, and this one is going to be, again, if we're working with grams, this would be hectagrams. And then finally we get over here to kilo, and then we have this is a kilogram. Again, each of these is 10 times bigger. So if we just had 1 gram, a decagram is 10 times bigger, a hectagram is 100 times bigger, and a kilogram is 1,000 times bigger than just your basic gram. Moving in the other direction, our next one down is going to be the deci. So here, again, if we were working with decigrams, it would be dg. 1/10 of a decigram is going to be a centigram. And then, of course, our smallest unit that we're worried about is milli. And again, if we are working with grams, we are looking at a milligram. And that is the abbreviation for that mg. Yesterday, we talked about an acronym that we could use to help us out with this, and it was King Henry died drinking chocolate milk. So King, starting over here, Henry died drinking chocolate, and then milk being our smallest unit on this end. In the middle, again, these are our bases. That just lets us know which unit or what type of unit we're working in. Hopefully that helps you out today as we work through our lesson. This is our first problem for our lesson today. We're actually going to go ahead and skip forward. And it says that Aaron is making fruit punch for a family reunion. He needs to make 120 cups of punch. If he wants to store the fruit punch in gallon containers, how many gallon containers will he need? Well, in this question, and just like all other questions, the first thing that I really want to ask myself is I want to ask myself, what is this question? Here it is at the very end. It's easy to find it because in our situation, it is usually finished with a question mark. So our question here is, how many gallon containers is Aaron going to need? The second part of problem solving is like, what information in here is going to help me to answer that question? I know that he wants to make 120 cups of punch. I also know that that punch needs to go into a gallon container. And that's all of my important information in here. It's always important to identify the important information because sometimes there's extra information that we're not really going to need. But here we're going to need all of this information. Then the final thing is like, what am I going to do with this information? How am I going to use it? And sometimes I'm going to make a chart. For example, in this lesson, they like us to make charts. Sometimes I might draw a picture. Sometimes it's as simple as figuring out, do I need to multiply, add, subtract, divide? What function of math do I need to do? But here we're going to make a chart. And the reason we're going to make this chart is because we want to show this relationship between cups and gallons. And they've filled in a lot of the chart for us here. In our first row here, it shows us that 1 cup is 1/16 of a gallon. And that is because if we have 1 gallon, then that is going to be equal to 16 cups. So 1 gallon equals 16 cups. 2 gallons is going, or 2 cups is going to be 1/8 of a gallon. 3 cups is 3/16 of a gallon, and so on and so forth. So hopefully what we're seeing here is that if we multiply the number of cups by 1/16, then we can figure out how many gallons we're going to get out of this number of cups. We also should remember that just as multiplying by a fraction, right? Instead of doing it this way, we could also divide by the denominator, especially if we're working with a unit fraction. So if we're working with a unit fraction, we can just divide by the denominator, which is what I'm going to do here. So I'm going to take 120 and I'm going to divide by 16. I'm going to make this just a little bit longer so that it's a little easier for us to work with. So 120 divided by 16. Use 7. So 6 times 7 is 42. 4 plus 7 is 11. I'm going to subtract, and that's going to leave me with 8 cups left over. So I need I have 7 gallons of fruit punch and 8 cups. But if I think back to that original question, remember that original question was, how many gallon containers will he need? Well, if I only have 7 gallon containers, then I'm going to throw away 8 cups, and that is not a good idea. So instead of using 7 containers, I am going to get 8 containers to store our fruit punch. Taking a look at our next problem here, it says Sharon is working on a project for art class. She needs to cut strips of wood that are 1 decimeter long to complete the project. If Sharon has 7 strips of wood that are each 1 meter long, how many 1 decimeter strips will she cut? Well, again, we're going to go through our problem-solving questions. The first one is, what do I need to find? And I need to find how many decimeter strips she can cut. The information I need to use to do for this is that I know that she has 7 strips of wood that are each 1 meter long, right? So that means that she has 7 meters of wood. And then we're going to cut that into decimeters. So I really want to figure out how many decimeters are there going to be in 7 meters. To solve this problem, I am going to know that I'm going from a meter to a decimeter, which is big to small. So I'm going to need to multiply. And I want to know what I'm going to multiply by. Now I can either use this conversion table up here, which they have provided. And the way that I would use this is I would say, well, I have meters and I want to change that into decimeters. And I see that 10 lines up with decimeters, which means that there are 10 decimeters in a meter. Alternatively, I could go through my acronym. So King Henry died drinking chocolate milk. And here I can see that my meter units are in the middle. Decimeters are one place to the right. So I'm going to multiply by 10. So again, she had 7 meters times 10, which means that we can get 70 decimeter strips out of her pieces of wood. We're going to look at just 1 or 2 more. Here we have Eduardo, and he has a drink cooler. It holds 10 gallons. He's filling the cooler with 1-quart containers. How many times will we have to fill the quart container to fill the cooler? So our question is, how many times is he going to have to fill the quart container to fill the cooler? We know that the cooler holds 10 gallons of water and that our container is only 1 quart. So what I'm going to do is I'm going to fill in the chart they've given us. I know that there are 4 quarts in 1 gallon. I know that in 2 gallons, there are going to be 8 quarts, and 3 there are going to be 12. And so as I look at this, I see that the relationship between gallons and quarts is that I multiply my number of gallons times 4 to equal the number of quarts. So if we have 10 gallons that we need to fill up, we have a 1 quart container. 10 times 4 gives us our answer, which is 40. So he will need to fill this container 40 times. Okay, here we're going to look at this one, and it says Kevin is making a picture frame. He has a piece of trim that is 4 feet long. How many 14-inch long pieces can Kevin cut from the trim? How much of a foot will he have left over? So I'd like for you to go ahead and pause this one really quick, try to solve it, and then start it back up, and we'll see how you did. So the first thing I'm going to do is look at this, and I have 2 questions. So how many 14-inch long pieces can he cut is question number 1. How much of a foot will he have left over? Because I have 2 questions, I need to have 2 answers. I know that we have trim that's 4 feet long. I know that I need to think about this in terms of inches. So the first thing I know that I need to do is I need to change 4 feet into some number of inches. Well, I know that there are 12 inches in a foot, and 4 times 12 is 48. So 4 feet is equal to 48 inches. I'm going to now think about that, and if I'm cutting it into 14-inch pieces, that is like repeated subtraction, and repeated subtraction is the same as division. So I'm going to divide here by 14. And 14 will go into 48. Let's see, 3 times. So 3 times 4 is 12. 3 plus 1 is 4. So I subtract, and I have 6 inches left over. So for the answer to my first question, how many 14-inch long pieces can Kevin cut from the trim? We can cut 3 14-inch long pieces. And then for the second question, which is how much of a foot will he have left over? Well, I have 6 inches left over, and I can easily convert this into a foot by dividing 6 by 12. I also know that 6 is half of a foot. So that means that we have 1/2 of a foot left over. So again, as we went through all of our problems today, the first thing we want to do is we want to ask ourselves, what is the question? Once we've identified what our question, we need to look at the information needed to solve the problem. After we figure out what information we need to solve the problem, we need to figure out how are we going to use it. In our lesson today, we used a lot of charts, but again, sometimes we need to draw pictures, sometimes we just have to add, subtract, multiply, or divide, but we need to figure out how are we going to use that information to solve the problem. And finally, I'm going to leave you with a story problem that I made up. It's not quite as fun as the usual ones, but I'd like for you to take a chance at this and try to solve it. And then what I'd like for you to also do is I'd like for you to post your own story problem at the bottom of this lesson for today. And ideally, it's going to be a story problem where we need to convert units of measurement. So this one says that James was practicing for a pasta eating contest. To win, he would need to eat 10 pounds of pasta in 8 minutes. He knows that 1 ounce of pasta is equal to 20 decimeters of pasta. How many meters of pasta will he need to cook to equal 10 pounds of pasta? But good luck with that. Good luck with the lesson, and let me know if you have any questions or need any help.